Today I'm going to be talking about the 5 types of reactions. So these are the 5 we've discussed. Synthesis reaction, what you're going to do there is you're going to have 2 separate things going together and making one new thing. In a decomposition reaction, one thing will break apart into 2 separate things. These reactions are also going to typically require some energy to make them happen. A single replacement reaction is going to be one thing replacing another thing in the reaction. And what you're going to need to check here is the activity series. Then we have a double replacement, which is going to be 2 things switching places. So you're going to see the B and the D switch places here. And that is going to be a solubility rules that you're going to need to check. And then a combustion reaction is going to involve oxygen. So if you have a combustion reaction with a hydrocarbon, carbon and hydrogen together, you're always going to make CO2 and water. And if you have a combustion reaction with an element, you just combine the 2, the oxygen and the element. It's a lot more like a synthesis reaction in that case. This list is also on your North Carolina Standard Course of Study reference tables, which look like this. It's on page 6 of those tables, and all the information that I have on mine is right here as well. So you'll have that on your final exam. So what we're going to do is we're going to use that information to determine the type of reaction. So I have a list here of some different reactions, and what we're going to do is we're going to label the reactions to help us determine the type. So for this first one up here, we have HNO3. So for every thing I see, I'm not going to have more than 2 things. For everything, I'm going to label it with a letter. So this must be 2 things bonded together. It's probably going to be a nitrate and a hydrogen. So I'll do AB there. Then I have a plus sign and Ca and OH. That's 2 things as well. So that would be CD. Then I can come down here. AB plus CD. That's how I would get my products, which means that this is a double replacement reaction. And so that's all we have to do to determine the reaction type is basically match up the letters. This next one I have one substance, Na, and I'm going to be adding 2 things to it. So A plus BC, is a single replacement reaction, so it's down here. And that's all we're doing for determining the reaction type. The next one, copper and iodine are going to go together. So I'll have one substance here plus 2 over here. It doesn't matter that that has a 2 next to it. As long as it's only one element, I don't need to put another letter. So A plus B is going to be a synthesis reaction. And all I'm doing is matching up these letters. This one has a lot, so you could probably guess it's going to be double replacement, but we'll go ahead and prove it. One element plus a substance, and then I have a plus sign, and then I have a bond between 2 different substances over here. AB plus CD does confirm that I have a double replacement reaction. And that is all we have to do. Some other things you might see would be substances that have an O2 in the beginning, like this one down here, H2 plus S plus O2. So I have A plus B plus C, and I'm forming one thing, A, B, C, or something like that. So it is a synthesis reaction, but it's not just a synthesis reaction, and the way I know that is because of this O2. Anytime you have an O2, it is a combustion reaction. The next problem, it does have an O2, but that O2 is in the end. The O2 is in the end, it's not going to count as a combustion. It's only if it's in the beginning. So this one I would have 2 substances bonded together. They are breaking apart into 2 separate things. So that would be a decomposition. So that's reaction types.